In this video, I'd like to continue talking about finding the amplitude of sinusoidal functions when we're given a picture of the graph. And for this example problem, we are told that the trigonometric function has a maximum point at this coordinate here and a minimum point at this coordinate. And there are two general approaches we can take for this. We can first figure out the midline, the horizontal line that cuts the function in half. That's not drawn perfectly to scale. And we can find that midline by finding the average of the maximum and minimum points, since the midline would be exactly in the middle of those. And from the midline, we can figure out the distance from that midline to the maximum or to the minimum y values. And that approach will certainly work, or we can realize that the distance from the maximum value to the minimum value, this distance would be twice the amplitude. Since remember that the amplitude is just the distance from that midline, let's roughly draw it in. It would be right about here. The amplitude is the distance from the midline to the maximum value, but it's also the distance from the midline to the minimum value. So the total distance from the maximum point to the minimum point is just twice the amplitude. And if we can figure out that distance between the 2 points, we just find their difference, then we can just divide that number by 2 to figure out the amplitude. So let's take the second approach since it's a little bit faster. We just find the difference in the y value of the maximum and the minimum point. We take the maximum value of 7.7, we subtract the minimum value, which is at negative 6.7. And since we're subtracting a negative, we're really just adding these values. And we find that this would just be 14.4. And we just need to remember that this is twice the amplitude. So to actually find the amplitude, we just divide everything by 2, meaning that in our case, the amplitude of this sinusoidal function would be 7.2 units. Now let's look at one more example problem where, again, we need to figure out the amplitude of a sinusoidal function. And we're told in this case that we have the minimum point and the maximum point. So it's just like the previous problem. And in this problem, let's use the other strategy. Let's figure out what the midline is, and then we can just take the maximum or minimum value and figure out its distance to that midline value. And to figure out the value of the midline, it's exactly in the middle of the y values for the maximum and minimum points. And if we want to figure out a value in the middle of two numbers, we can just find their average. We can add them together and then divide by 2. And when we take 11.4 and we subtract 5.5, we find a value of 2.95. And this will be our midline of the function. We can graph this line now at 2.95, so roughly right below a y value of 3. This is not going to be drawn perfectly, but we can get a general idea of where it is. And we know that the amplitude is just the distance from that midline to the maximum, or the distance from the midline to the minimum. It should be the same for both. And since we know this has a y value of 2.95, the y value of the midline, we could take the y value of our maximum, which is 11.4, and subtract the y value of this minimum to find an amplitude of 8.45. And of course, we can check this by doing the same thing over here. We can take our y value from the midline of 2.95 and subtract off the y value of our minimum, which is negative 5.5, so we're really just adding those values together, and we will also get this 8.45. And since we got the same value in both cases, we can feel confident that the amplitude of the function is 8.45 0.45 units.